Hey, welcome back. So in this lecture, I want to wrap up this first section of the Apple Picker project. At this point, we have the basic game loop, but we don't really have any sort of score keeping yet or anything like that. We have an apple tree that spawns apples, and we have a pedal to collect that with. We have our camera set up and everything like that. But before we wrap up and move on to the next section, we want to do some cleanup. And this is a good practice to get into. Before you take on the next major task for your project, it's a good idea to go through the classes that you have written up until that point. Maybe check for spelling or typing errors or to add additional comments. It's also a good time to think about class defaults such as AutoPossessPlayer, or whether we want to set Simulate Physics to true by default for the class if it makes sense to do this. Hopefully the code is self-documenting, so the reader may have an understanding of what's going on based on their knowledge of C++ and Unreal Engine, but they may not understand exactly why you are doing that, so keep that in mind when you are writing your comments. It's also a good idea to check for consistency issues, so in the treebase.cpp, in the initialization list for the constructor here, notice that for inner boundary I have used brace initialization instead of the parentheses. So for consistency I will change that from braces to parentheses. As I mentioned, we can also add comments, so in the change direction function I will add why we have this code here, not what it does, because that is obvious from what is going on from the code, but why. We only want the apple tree to redirect when it is within the inner boundary. I will add a comment on that. Of course you don't have to do that, that really depends on you, but this is just one example of a comment that you can do. I will save that. Then I will navigate to the basketbase.cpp. In the constructor, we can assign eAutoReceive input player 0 to AutoPossessPlayer. AutoPossessPlayer is going to determine which player controller, if any, should automatically possess the pawn when the level starts, or when the pawn is spawned. Remember that we set that setting to player 0 with the pawn selected in the viewport. So I'm just demonstrating how we can set that programmatically here in the constructor, for example. I will build around this so we can see what's going on. So back in the editor here, I will select the pawn that we have here in the viewport, that basket pawn. I will navigate to the pawn section, and here we have AutoPossessPlayer. We have that set to player 0 by default, as I mentioned, but I just wanted to demonstrate how we can set that in C++. So we have that as the default for the class. The mode option is used to lock the physical movement along an axis. Now in the Unreal Engine 4 we could also set this in C++, and I wanted to demonstrate that, but I'm not going to for this particular lecture here because I keep getting editor crashes. If we were to look at the tooltip, it says PhysX only, which could be why, since the new Chaos Physics system replaces PhysX. I'll skip this option and I'll show you a different way of locking an axis. We can navigate to the AppleBase constructor, so in the applebase.cpp, from the Apple Mesh component, from that pointer, since that is pointing to a static mesh component, I will use this function set simulate physics, and I will set that to true. And now if we go back to the editor and we go and check that, that will be set by default for the class. Back in the physics section, we can lock the rotation, since the apple does not have to rotate. We can also lock an axis, since the game basically plays on a plane, and we don't want those apples to escape us. We can lock the movement along whatever axis we specify. You might think, okay, we want the apple to move freely in the Y and Z axis, so we will set that and compile. But if we play, we will notice that the apple does not fall anymore. Remember that this option locks movement along the specified axis. You can always check that little compass in the bottom left corner of the viewport to reorient yourself. That is when you try and deduce which axis you need to lock. So what we actually want to do is we want to lock the movement along the x-axis only. If we compile now, compile and save, go back and play this now, then those apples will fall down, simulate physics and behave as we would expect. Just a couple more things that I would like to note. So in the tick function here in the treebase.cpp, we have the section here where we do the offset and then we set the new location. Now what we are doing here is we have this movement speed, which I'll go to the treebase.h, movement speed. If I scroll up, that is a float, not a vector. So what we could do is, if we navigate to the basketbase.cpp, remember that in the tick function here, we also do an offset, but in this case we use a velocity, current velocity. If I navigate to basketbase.h, current velocity is actually a vector, alright? So that is one thing that you could change if you want. I'm not going to do that for this. This is just again a demonstration. For this it really doesn't matter all that much, but what is nice about the vector, if you think about it for a second, if you have the vector, two of the members will not be affected, for example. Let's say do movement along the positive right vector, which is positive y. Then of course the other two members of that variable, the vector, will remain unchanged, and in that way you prevent that sort of offset on an axis where you don't want that movement to happen. So that is really the difference that you will have. Instead of using a float, you may want to use a vector, but again for this demonstration I'll just stick to a float here. Something else I want to demonstrate is calculations such as this. Remember that I mentioned movement speed is a float. It is going to multiply with -1. So this is a small thing, but if it's an integer, then it does a promotion, which is a conversion. And of course, every implicit conversion like that is going to add to compile time, for example. So you want to make sure that you check for small things like that. It's a really small thing, but you can check for that and in that way avoid those implicit conversions. And that's about all of the changes that I will make for right now. With that, we are going to wrap up this lecture. Again, this lecture is not really to go over everything that you have to do. I'm not necessarily thinking about everything, I'm not commenting everything. You may come across something that you may feel that you want to comment or that you want to change and update at this point, but the point of this lecture was to demonstrate to you and highlight why it is useful and important to go back every once in a while, to sort of take a break and to go through your code and to clean things up a bit. Alright, we are not quite done with this project yet, I do have another section planned, but for right now that is going to wrap up this lecture. I'll see you next time.